Welcome to Meki Study Circle channel. In this video, we shall see how to do the computer drafting of the development of the lateral surfaces of the solids using the Solid Edge software. In this problem, we have a cube of side 40 which is resting on HP with its base on HP such that one of its vertical faces is inclined at 30 degrees to the VP. It is cut by a section plane perpendicular to VP inclined to HP at an angle of 45 degrees and is passing through the midpoint of the axis. We need to draw the development of the lower lateral surface of the cube. So if you understand the problem statement, we can come at certain conclusions. That is, the given type of solid here is a cube, and all the sides of the cube measures 40 Next is the resting condition. It is resting on the HP on its base with one of its edges inclined to VP at an angle of 30 degrees. And next, coming to the cutting plane condition. So the cutting plane is passing through the midpoint of the axis of the cube at an angle of 45 degrees. So this is the data that is given to us. So with this data, let us see how to draft the solution for this problem statement. As per the problem statement, the cutting plane is passing through the midpoint of the axis and is inclined to HP at an angle of 45 degrees. So in order to consider the midpoint, we can just go to the IntelliSketch and select the midpoint option, so that if I just move the cursor on the axis line, that is O1 dash and O dash, I'll be getting the midpoint. So now I can go for the line option and place the line at this endpoint or the starting point of the line at the midpoint of this axis O1 dash O dash, and then try to construct an angle which is inclined at an angle of 45 degrees. So this is the cutting plane. Use the extend to next option to extend this cutting plane to meet the XY line. So we can just consider which all edges will be intersected by the cutting plane. So use the trim option, trim this portion. So this is the cutting plane. So let us denote the cutting plane by this line. So this is the cutting plane. So again, go for the line option, select a continuous line. So before we draw the complete view, what we can do is select a line of thickness 0.50 and then just darken all the lines that is cut by the cutting plane, that is the lower lateral surface of the cube. So this is the surface that is left out after the cube is cut by this cutting plane. Okay, so now the next step here is, in order to get the actual top view of this cube, so what we can do is select a line of thickness 0.13. So from these endpoints, let us just try to intersect the top view of the cube by drawing the lines downwards. So again, select the line option of thickness 0.50 So we have got the endpoints to be connected. So this completes the top view of the cube that is remaining after the cutting plane has chopped off the upper portion of the cube. So now we need to draw the development of this part. So in order to do the development, let us indicate the points which is being intersected by this cutting plane. So we'll start from this edge, that is A1 dash and A dash. So here the cutting plane is not having any point of intersection with this edge. So as per the problem statement, we need to start from the next edge, that is B1 dash and B dash. So let us consider that before B1 dash and B dash, in the edge that is A1 A to B or A1 to B, it is intersecting at point 1, and let us denote this point as 1 dash. And next, also from B dash and B1 dash, it is point 2 dash, and here will be the point 2, that is the top view of the point. And next we have got C1 dash and C dash. So here the this edge is not indicated or intersected by any of the cutting plane, so we are not having any point here. But however, B to C, here we have got the point 3, and here B to C is in the back end, so we can just assume that the point will be here, so we can call it as 3 dash. Okay, then we have got C to D, so we have got this point as 4. So C to D is also here. So here itself I can denote the point 4 dash also. So this is nothing but 3 dash comma 4 dash. So CD is not visible to the observer. So we can just indicate that inside the bracket. So next we have got the edge, that is D1 dash and D dash. So this edge is also not visible to the observer. And here we have got the point 5 dash. So it can be shown inside the bracket. So these are the salient points that we require for constructing the development. So as the procedure, so first we'll consider the opening of the cube. So when I open a cube, I'll be having a square of 40 cross 40, and there are totally 4 faces. So what I can do is I can draw a line of total length equal to 160 mm, that is 40 into 4. So select a line of thickness 0.13, and now let us construct the square faces. So ensure it is of thickness 0.13. So it is having a height of 40 mm, followed by the width also, which is equal to 40 mm. So we shall construct 3 other square faces of the cube. So these are the cut open section of the cube. So we can just do the annotation. So this is A1 and this is A. Similarly, I can call this as B1 and B, while this is the edge C1, C, and this is the edge D1, D, and back to the point of intersection of the planes, that is A1 and A. So this is the cut open part of the cube. So we can just show the dimension. The entire line is 160, and the distance between any two corner points is 40 mm, and also the height of this will be equal to 40 mm. So now we need to have this salient points 1, 2, 3, 4. So as we can see that we do not have any point on A1, but however from A to B, so we have got this point 1. So what we can do is go for the distance between and measure the distance between A1 and this edge, which is equal to 14.64. So also next we have got to mark this point. So go for the line option. So from A1, draw a line of length 14.64 on the edge A1 B1. So we'll be having this endpoint. So from here we can start the development. So this is the point 1. So go to the annotation and annotate this point as 1. And next we have got the point 2 on this edge B1 dash and B dash. So we can just represent that by drawing a horizontal projection line and intersect the edge B1 B. So this is the point 2. Next, coming to the edge C1 dash and C dash. So we do not have any direct point on this edge, but however, B to C, we have got B1 and 3 here. So what I can do is I'll go for the distance between and measure either the distance from B1 3 or C1 and 3. So I can do it either way. So I've got 8.45. So what I'll do is, so I've taken it from C to B. So I'll draw a line from C1 to B1, and the length of the line will be equal to 8.45. So here I'll be having the point 3. Next, we have got the point 4, which is on the edge C1 and D1 or CD, that is the top face of the cube. So again, go for the distance between from C to the point 4, measure the distance, which is equal to 14.82. So let us construct this distance again from C to D. So go for the line option. From C to D, draw a line of length 14.82, and then drop a line so that you get this point 4. So the point 4 is here. Then the point 5 is exactly on this edge D1 and D. So we can represent that by drawing a line, horizontal projection line, and intersecting the edge line D1D. And this point is 5. And again from D to A, we can just measure this distance or simply A1 to D. So we can annotate this point as 5 first, and then we can take up this point as uh, 6, and also this will be 1 comma 1 dash comma 6 dash in the front view. So what I can do is I can go for the distance between and measure the distance between A and 6, which is equal to 8.45 again. So A to D, I'll be getting one more point. So A1 to D1. So let us draw a line of 8.45. So this is the point 6. So again we can draw a line from this point also. So we have drawn a line that is equal to 14.64. This is the point 1. So now go for the thick line, that is 0.50 mm line. So from 1 to 2, 2 to 3, 3 to the point 4, 4 to 5, 5 to 6, and then connect this 1 to 6, and similarly draw the edges. So we are going to darken only the edge lines. These construction lines are not required. So now we can write the development and then complete the solution for the given problem statement. So it is better we include this development within the darker portion or the cut portion of the cube. So to summarize, we have got a cube with the resting condition as one of its edges inclined to VP at an angle of 30 degrees. And then we have got a cutting plane which is passing through the midpoint. So you can just show this. So the distance between the point of intersection and the base of the pyramid is nothing but the midpoint. So that is 20 mm. And then it is also inclined at an angle of 45 degrees. So this is the angle of 45 degrees. So this is the cutting plane condition. So these are the points, the salient points at which the cutting plane is going to intersect the faces of the cube, and we are going to develop the lateral faces of the lower portion of the cube as per the problem statement by following the procedure explained. So with this, we complete the drafting of the solution for the given problem statement. Thank you all for watching.